Thank you, Tyler. This presentation today should be called part two of a two-part series. That's not how it's labeled, but it is on standards. And those of you that were with us last week know that last week we talked about generators and the National Electrical Code. This week we're going to pick up on the other codes, but because standards are so intertwined, we'll be talking a bit about the National Electrical Code so you understand how that interfaces with these other standards. A couple of things I want to say by review before we get into this. Number one, there are three types of generators. And when I say three types, I'm speaking National Electrical Code. So the first type of generator is a life safety generator. This is a generator that could cause someone to die if it doesn't work. And the way to think of that generally is it could either be a generator that's necessary to evacuate a building, let's say to operate the elevators in the building or to operate the evacuation lights. Or it could be an elevator, let's say for a hospital, that is necessary to provide power to someone who's in surgery or in intensive care or the emergency room. Those are definitely emergency generators. Now, an emergency generator, according to the EPA, is a totally different thing than an emergency generator for the National Electrical Code. The EPA just says an emergency generator is one that's there to back up a utility. So they do that, I think, to make sure that we're properly confused by labeling things the same that are not the same. But we're talking about the National Electrical Code. That is NEC Section 700. NEC Section 701 are legally required generators. Now, legally required generators could be generators that could cause health hazards. Let's say something like a sewage treatment plant. Nobody's going to instantly die, but it certainly could create a health hazard if that generator doesn't work. There are also generators that can hamper rescue or firefighting. That's NEC Section 701. Then we have optional standby generators, and that's NEC Section 702. Now, if you buy from Generac, from Cummins, from Kohler, from CAT, a light duty generator, let's say a residential generator or a commercial quality generator, those generators cannot be used as emergency generators or as legally required generators. And it's a real heartbreak because if you go to an electrical distributor and buy a generator, they don't have access to the emergency or the legally required generator product line. They're going to sell you an optional standby generator, and then along comes the authority having jurisdiction, that would be your fire marshal or your local inspector, and he says, show me the remote annunciator, for instance, and you call us and say, hey, I need a remote annunciator. We say, we're really sorry, but you bought a generator that doesn't have a 21 light remote annunciator available because you didn't buy the industrial generator that complies with emergency and legally required standby. So that's a heartbreaker for me because the only way to fix that is buy another generator, and that's just breaks my heart to tell somebody that. So I want to set the stage for that because we're going to talk about that coming up. Standby generator standards and codes. Well, here's the listing agency. It hasn't been long ago that UL was not required on a standby generator. And if you watch this presentation in a country other than the United States, that may still be true. But these days, you better make sure that your generator has a UL sticker on it. It could have an ETL sticker on it. That's fine because the code says it has to be a nationally recognized testing laboratory, and ETL is one of those. So if ETL tests your generator, they test it to UL standards, and it's just a different agency that tests it, but it's tested to the same standards. So make sure that you have that regardless of what generator you buy, because it's not something that we can just run out and put a sticker on it in the field. You may need a special UL inspection. They're costly. So that is important in the United States. Here's some UL requirements for tanks. There's a couple of types of tanks, and we will show you pictures so you get a better feel. There's a UL 142. Generally, this is a tank that goes under a generator. It is typically a double wall tank. Then there's a UL 2085. These are the monster tanks, the tanks that have lots of testosterone. Then we have switching equipment. Typically, that's your UL 1008, which is transfer switches. If you have a switchboard, it'll need to be UL 891. And if you have metal enclosed low voltage power circuit breaker switchgear, that's 1558. And then finally, you have your generator, which is UL 2200. So all of those really need to be UL. This is your first type of tank, your UL 142. And this is a great picture, I think. The first thing to note is this empty spot here on the end. Now, of course, typically there's going to be a piece of sheet metal on that side wall there, but this is basically your conduit entry. The tank gives you a space to route conduits, and that's pretty great as long as the conduit comes up in the right location. Now, the conduit always comes back on the end of the tank. You need to make sure that you get the right end, but I have never seen any tank built that had a conduit entry in the middle or on the sides or anything like that. It's always on one end. So it's very important that that be known, the location, before you put your conduits, because typically the conduits are going to be in cement and are not easily movable. This is a double wall tank. You can't really see the two walls, but on 5 sides, the 4 sides and the bottom, it will have 2 walls, and that is for leak detection. So if you get a leak in the inner tank, it will go into this area between the 2 tanks. That would be the leak detection basin, or there's other names for that. And then you see this this wire right here that goes to that sensor on the end. It's right there on the bottom, and it will detect that leak and alarm, and you can do something about it before you end up with oil leaking on your cement. Right here on the very end, and right here in the more on the top, that's called your emergency vent. Emergency vents are not required. They are optional, but they are required on an emergency generator. And so it's important that the manufacturer of your generator know that it's going to be an emergency generator so that they can apply those to the tank, because that's a requirement that exists there. Right next door here, the silver piece, is your normal vent. And your normal vent, of course, just allows that tank to breathe. When the air gets warm inside, then you don't want it to push the sides of the tank out and create a high pressure. So that normal vent just allows some air to come out. When it gets cold, the air goes in. And unfortunately, air has moisture, and that moisture will condense. And all tanks over time will accumulate a little water. Now, since water is heavier than diesel fuel, the water will accumulate on the bottom of the tank. These tanks are prototype tested to 15 psi. So they'll build one tank, they will test it to that, and they do that when they're getting their UL rating on that tank. But in production, we don't want to take any chance of damaging a tank, and so the production units are tested to 3 psi. This is your monster tank. It's a UL 2085, and most people just refer to this as a Convault tank. Now, Convault is one manufacturer of 2085 tanks, but it's like if we get a Pepsi, we usually call it a Coke. And there are a lot of manufacturers of colas, but we just tend to call them all Cokes, and that's the same way with Convault. So a Convault tank could actually be built by other manufacturers and wouldn't actually be a Convault, but it would be a UL 2085. This is a monster tank, as I said, and if you look at the cutout here of the sidewall, it shows you that there's a steel tank on the inside, 1/4 inch of polystyrene, 30 mils of polyethylene, and then a full 6 inches of concrete that is steel reinforced. So that is the case on all 6 sides of this tank. You can generally run into this tank with a car and it will not leak. You can, and they have a big billet. They smash into these tanks when they're testing them. and that is a very stout tank. It also has a 2-hour fire rating. That means you could build a fire around that tank, and it could prevent any combustion of the diesel fuel in the tank for 2 hours. These tanks are, well, I've never seen one that's been mounted indoors, and indoor tanks typically are limited to 660 gallons. So these are typically outside, and that is also going to require you to have a smaller tank inside and to have a fuel transfer system, which complicates things. So I'm not a big fan of 2085 tanks, but there are some jurisdictions or some customers that will require them. UL 1008 covers transfer switch equipment, but not all transfer switch equipment. It only covers transfer switches rated up to 600 volts. If it's higher than 600 volts, it is a different standard, and to 6,000 amps. Switchboards and switchgear have their standards, and one of the things that can be confusing is people will write a spec and will have, let's say, a couple of circuit breakers in the generator, and they'll say, oh, those circuit breakers must comply with UL 891 for dead front switchboards. Well, we can't do that because you can't have 2 UL stickers on the same piece of equipment. The things are tested to one particular standard. So for example, if you have a coffee pot, that's UL 1082. A microwave oven is a UL 923. But microwave ovens will not have a UL 1082 sticker showing that they are a UL approved coffee pot. And so by the same token, any switchgear inside of a generator is part of the UL 2200 standard and not part of the 891 standard. Here's your dead front switchboards. A dead front switchboard is UL 891. And if you buy this from a credible manufacturer, you'll have a hard time finding a switchboard like that is not UL. These are the metal enclosed low voltage power circuit breaker switchgear. I love these things. Again, this is just switchgear with a little more testosterone. Sometimes call these metal frame circuit breakers. And they are used in heavy duty industrial installations. When I was the director of engineering for Geneva Steel, we always bought this type of switchgear because it was heavy duty, had high withstand ratings, and it could be maintained. Whereas a insulated case or molded case circuit breaker, you can't really maintain those. You're supposed to leave them sealed. So these are generally heavier duty in industrial installations. And finally, we get to the most important, that's UL 2200. We're going to talk a lot more about that in coming slides, so I'm not going to spend a lot of time on it here, but make sure that your generator has a UL 2200 sticker on it. The inspector may want to see that. So UL 2200 says it must be listed for entire use. It places importance on the entire unit. They test fuel systems as well as the other components. It is your insurance that it is a safe product via the product construction, and it requires lots of performance tests. These are just some examples. For instance, you see over there in that picture in the upper right, see how it says hot there? Well, it turns out the reason it says hot is that is actually part of the UL standard. Now, this is a Generac generator. It's cut a piece of metal there, and the hot is actually stamped into the metal, which is great. Some other manufacturers, in order to save money, now just spray paint that on there, which is not as good, but excuse me. That's part of the UL standard to say it's hot. Well, you say, you know, what kind of a moron would not know an engine can be hot? Well, it's part of the safety standard. They have standards for raw material quality. They have standards for corrosion. And I believe we have a slide, let me look, yes, it'll be here in a minute, about corrosion. Assembly standards. Turns out that every bolt in that generator, if it's a UL generator, has to be torqued and will have torque specifications. And finally, anything inside the generator is going to have to be either UL listed or UL recognized. And you probably know a UL recognized component is a component that's not meant to be purchased by itself. It is a component that's used inside of another device. So things like air filters and battery chargers and switches and so on, they have to all be either UL listed or UL recognized for the generator to be UL. We do a temperature test. We make sure that the engine alternator, the surfaces and the controls and everything do not get hotter than a certain amount as specified by UL, which is different for different parts of the generator. The alternators have to go through dielectric voltage withstand harmonic distortion tests. And then the enclosure, we do an impact test. So that means you have to smash a billet into this thing and it has to hold up. And we do salt spray tests. So they put it in a little, what do I say, an enclosure, it's not a very good word, but in a room, and seal the room and spray salt on it. And then they go in there after a certain amount of time and look for corrosion. Finally, they go in and they actually block the inlets with so that there can be no airflow. They put some cotton in there and they spill some fluid and they make sure that it's not going to catch fire. So UL is a pain, but if you get a UL generator, you get lots and lots of tests and requirements. The previous slide only give you a sampling of those, and it really is a great certification. It's a great knowledge to you that that generator is a very high enclosure generator that has met all those standards, and the engineer doesn't have to specify all those. He just has to specify 2200. Here's some more things. Rain tests. Make sure there's no water leakage into the electrical boxes, and they do water spray. And then parallel testing is on generators that would have integrated paralleling. We've already talked about integrated paralleling in other webinars. And finally, you get your sticker. Again, an ETL sticker and a UL sticker really are both the same. It just is a difference in whether you had it tested by UL or tested by ETL, but they both test to the UL 2200 standard and certify that the generator has met all those standards. Now let's get into NFPA 110 as well as some other standards. These are show standards that exist for generators. We don't have all day, and so we are not going to go through all of those standards. But NFPA has standard 20 for fire pumps, standard 37 for stationary engines, 54 for the fuel gas code, 58 for liquefied petroleum gas, 70 is your national electrical code, 99 is healthcare facilities, 101 is the life safety code, and finally 110 is your standard for emergency and standby power systems. Now, if you have an optional generator, you do not need to meet NFPA 110. If you have an emergency generator or a legally required generator, then you do need to meet NFPA 110, and not all generators are built to NFPA 110. It turns out that because there's so much information in NFPA 110, that the National Electrical Code actually punts a little bit and assumes that you're going to meet NFPA 110, and so they don't duplicate all those requirements in the National Electrical Code. For instance, the Life Safety Code requires you to comply with NFPA 110. The NFC references NFPA 110 in many fine print notes, and as you can see, for emergency systems and legally required systems, you must comply with NFPA 110. Finally, your NFPA 99 requires NFPA 110. So NFPA 110 is something we should talk about. Now, NFPA 110 is not nearly as large as the National Electrical Code, but the National Electrical Code only has a small portion of it devoted to generators, whereas NFPA 110, the entire thing is devoted to generators. So there's really more requirements and information by far in NFPA 110 than in the National Electrical Code. So let's take a look at level 1 and level 2. Again, they do it this way to make sure that you're properly confused. An NFPA 110 level 1 generator is a generator where failure could result in loss of human life. Well, where have we heard that before? That's NEC 700 for an emergency generator. So basically, if you have an emergency generator, it must meet NEC 700, and it also must meet NFPA 110 level 1. If you have a level 2 generator that says it is less critical to human life or hazards or hampers fire rescue. A little bit different wording, but that sounds a lot like NEC section 701 for a legally required standby generator. So remember that the NEC and NFPA 1 are written by different committees, and so you're going to find different wording in there. But generally, whenever you look at NFPA level 1, we're talking about an emergency generator, and when you talk about level 2, we're talking about a legally required generator. There are 3 types of fuels. There's diesel, there's liquefied petroleum, and there's natural gas. A lot of people think LP stands for liquefied propane. Actually, LP could be propane, it could be butane. In our area, we don't use butane because it does not vaporize as well as propane, but butane is used in warmer countries, down maybe in Central America. Now, if you have a level 1 application, you need to have on-site fuel, right? So you would not be able to use natural gas. Well, that's not true. There is an exception there. And it says for level 1 installations in locations where the probability of interruption of off-site fuel supplies is high, on-site storage of an alternate energy source sufficient to allow full output of the EPS to be delivered for the class specified shall be required. So this says that you can use a natural gas generator if the probability of interruption of your natural gas system is not high. Well, in one of our earlier webinars, which is still available online, we had Questar Gas, which is what Dominion Energy now, come on, and they talked about a recent earthquake that they had. And we said, where did you have natural gas interruptions? And they said, well, there was some places where homeowners turned off their natural gas. There were some other places where some mobile homes fell off the bricks that they were standing on and tore the supply loose. That was about it. Natural gas pipes are very, very resistant to earthquakes. They're used now plastic materials rather than metal pipe. And I think of my water heater here. I've been in my house now since 2004. That's 16 years. I have never had a natural gas interruption. And they will say that within maybe 0.01% or more than, or even finer than that, the reliability of natural gas fuel in this area is pretty much 100%. And so most fire marshals will allow natural gas for generators on things such as hotels, for egress, and so on. Now, if it's a full-scale hospital, typically that's not the case. We're going to want some very, very large diesel tanks there. But my opinion is that you're better off with a natural gas generator in things like hotels, because diesel generators are very maintenance intensive, and you have to test the fuel, and the fuel might need replacing. And so in general, natural gas generator is more likely to be operable in a power outage or in a disaster. And a lot of people say, well, in an earthquake, that may not be true, but actually we find that it is true. In areas where there are earthquakes, the government in their studies have found that a natural gas generator is more likely to be operable than a diesel generator. So natural gas is increasing in popularity. And but before you use a natural gas, you really want to check with your fire marshal, make sure that it's okay with him if it's an emergency generator. Now, if it's an optional generator, then of course they don't care. You're perfectly able to use natural gas. And we're finding that diesel sales are pretty stagnant. I mean, they're still here, and diesel generators are going to be here for a long, long time. but natural gas generators continue to increase in popularity, and every year the percentage of natural gas generators goes up. All right, diesel fuel has to be maintained to be reliable, so the fuel system design shall provide for a supply of clean fuel. How long does diesel fuel last? Well, it turns out that we don't really know. I've certainly heard a lot of stories from farmers and such that they have diesel fuel that's 20 years old and they stick it in their tractor and they are able to use it. If you go on the website to Shell or to Chevron or Exxon, a lot of times they will tell you that diesel fuel should be good for at least a month or maybe even 3 or 6 months. Well, that doesn't help us much in the standby generator industry where that fuel is going to be in that generator for decades. So it turns out that we need to test the fuel. And typically, if you're going to test and maintain the fuel, that fuel will last many, many years. So a fuel quality test must be performed at least annually. And the new NFPA 110 for emergency generators now says every 6 months. Most people don't do that. And when I'm giving this presentation in person, I get to that point, and a lot of times I see people look at their buddies going, "Did you know that?" Well, you need to do that annually, and then you need to maintain the fuel. You need to check to see how much water is in the fuel. If that water gets high enough to reach the input of the generator where the fuel is sucked up into the generator, and that's typically 1 to 2 inches above the bottom of the tank. Once you start sucking water, your generator is not going to work very well. Furthermore, your generator is going to be I'm sorry about this. The generator, in cold times, the fuel can gel, and so you need to have anti-gelling compounds to make sure that it doesn't gel at the lowest temperatures that you're going to use it. And you're going to need antibacterials because you can have bacteria grow. They generally grow at that interface between the water and the diesel, and that can go in and clog your fuel filters. So it's very important that you do these tests and that you maintain your diesel fuel. And there may be times when you literally have to drain the tank and put in fresh diesel fuel or circulate it through filter systems that can restore that diesel fuel to the quality that you require. Now, if you have an optional standby system and you have a 24-hour tank, and engineers many times just specify 24-hour tanks, often without even thinking about how much fuel they're going to need, that fuel is going to be in the tank for almost 13 years. Well, that's a long time. So it tells you why it's important that you maintain that fuel. Now, if you have an NFPA 110 level 1 application, we're talking about an emergency generator, that fuel still could be in that tank for almost 6 years. And so we should think about, when we're sizing our tanks, how much fuel we really need. We may want a 72 or a 96-hour tank if it's really critical that that generator be able to run long periods of time. But what if you have a hotel and you're just wanting to evacuate people from the hotel in a fire? Well, I think it's pretty unlikely that that fire is going to last 24 hours. And so many inspectors will be perfectly fine with an 8-hour tank in an application like that, and there's less fuel for you to take care of. All right, we talked about fuel maintenance, and if you look down at the bottom, there's some diesel fuel failure modes: moisture, gelling, biomass, fuel instability, varnishing, storage, leaking, running out. That's a big one. Let me mention that the number one reason why standby generators fail is the battery system. Either we lose the battery or we lose the battery charger. The number 2 reason why generators fail is the fuel system. And in many cases, that's a clogged fuel filter. I have told this story, I think, before. It's like people with only a hammer think everything's a nail. And I'm kind of like that because I'm an electrical guy. And I remember being up there testing a generator that was having some instability problems. and we thought it was due to electrical harmonics because there were drives on there. And we spent like a whole day trying to figure this out and trying to reduce the level of harmonics and so on and so forth. But Generac, at least with their three-phase RMS voltage sensing, have been very, very reliable in terms of harmonics. So I was a little stumped, and the next day they brought up a load bank and tested it on a load bank, which is entirely linear load. And once they got above 95% load, it went unstable, the same as it had before when we were testing the VFDs. What was the problem? It was a partially clogged fuel filter. And so I was a little chagrined by that I spent so much time on there and never suspected that it could just be a dirty fuel filter. So we replaced the fuel filter, all the problems went away, the generator was stable, it had nothing to do with harmonics. That's the number 2 reason for generator failure, fuel system failure of some sort, and that tends to be clogged fuel filters or dirty fuel that is either gelled or has water in it or so forth. Now, how much fuel is enough? We talked about this a little bit before. You want enough fuel that you can run the time that you need to run. And if it's a hospital, you're going to want a lot more fuel than if it's a hotel where you're simply trying to evacuate people during a fire. So think about that when you size the fuel tank. There's no right answer. There are requirements, for instance, for hospitals, but in most cases, that's really up to the supplier, the engineer, and the authority having jurisdiction. Now, if you have a level 1 generator, you've got to have a minimum drawdown. The fuel tank has to be 133% of the required class. So, for instance, if you need a 6-hour tank, you're going to have 8 hours of fuel in that tank because of that 133% requirement. Your low fuel level needs to be set at 100% of the required class. So if you feel that you need 4 hours in order to properly evacuate that hotel, you're going to set your low fuel level at 100 at that 4-hour mark, and that tank may still be half full. But when it gets to that point, it's going to give you an alarm, a low fuel level alarm. It needs to be capable of operation after a seismic shock in areas where that's required. Inside tanks are generally limited to 660 gallons. This is something that comes up quite often. You can go over 660 gallons, but now you're going to have those that tank in a dedicated fire room, and you're going to have spill containment. And probably more important than either of those things is you're going to have a little conversation with your insurance company, because many times insurance companies will want sprinklers in that room, and they may want diesel fuel detection. We put some generators in a hospital up north here, and they wanted sensors on the cement that would detect a diesel fuel spill. So you may have other requirements from your insurance company. Now here's your fuel piping requirements. I'm not going to go over all these. You can just kind of scan down there. And while this may look common sense, and it is common sense, these are often neglected and may not be there. Oops, excuse me. Some more diesel fuel piping requirements. On the right-hand side, you see a picture. That's a day tank. So you have a very small tank, and this would be used where you have a large tank outside so that you can have lots of fuel. And then when that day tank gets down to a certain level, it will turn on a pump and pump fuel from the generator outside into that little fuel tank there. And that works pretty well, but you need to realize that it's got to work. If that pump doesn't work, if the sensors don't work, you may have a problem. And so we don't have time to get over the proper application of day tanks, but with day tanks, it depends on whether the day tank is higher than the generator or lower than the generator. And I didn't say that right. Whether the main tank, not the day tank, whether the main tank is higher or lower than this day tank, and that will affect how the pumping system works. and the things that you need to have in there. So it can get quite complicated, and you can see some of the issues here in the tanks. One of the things that you need to have, whether it's a day tank or a sub tank under the generator, is that the fuel vent should terminate outside the building. That is generally not enforced if you have louvers that are just open all the time. But if you have motorized louvers, so the building is somewhat sealed, which a lot of people like because they can keep the generator room warmer, then you need to make sure the vents terminate outside the building. And there's lots of other requirements many times that are not done. Now here's the top of a tank, and we talked about that before. Over here on the right is your normal vent, kind of down on the bottom there, at least bottom of the pitcher, not the bottom of the tank. There's your emergency vent. This is just a spare opening. This is your sensor for fuel. I'm sorry, I said that wrong. Here's the emergency vent right here. Here's your fuel fill. There's a fuel level gauge. And then, of course, with diesel generators, you have two fuel hoses, one that feeds fuel from the tank to the generator, and one that feeds fuel back from the generator to the tank. And modern generators have very little fuel that goes back to the tank. Older generators will have a lot more. That is hot fuel, and that is another requirement you need to consider if you're looking at a day tank. You don't want that day tank to get too hot. This shows a close-up on the left. You've got your fuel gauge, and this is in what we call the rupture basin. The rupture basin is that area between the two walls of the tank, so you know that if you have that sensor show fuel there, then you've got a leak inside that inner tank or a rupture of the inner tank. On the right is your emergency vent. That's just always closed. They're generally around 4 inches, but could be smaller or larger depending upon the size of the tank. And they are there to prevent the tank from exploding in the event that you have an explosion inside the tank. And so that cap there in an explosion blows off. I have never seen this happen. And that's why you don't actually have to have that there. You don't need an emergency vent unless it's an emergency generator. Here's your gas piping requirements. One of the main problems we have when we first start up natural gas generators is that the pressure drop in the pipe is too much, and the generator chokes and then dies because it's not getting enough fuel. So what you want to do is you want to bring in your fuel from wherever it is at whatever pressure you can get. Generally, the higher the pressure, the better. That's not always true. But you would bring it in, and then you have another fuel regulator, a natural gas regulator here, and that would be set for whatever the requirement is for the generator. So for instance, residential generators need about 5 to 7 inches of water, and most larger generators, let's say 100 kilowatt, 200 kilowatt, 500 kilowatt, they'll generally be rated 11 to 14 inches of water. There's about 27 inches of water in a PSI. So you're talking about roughly half of a PSI. It's not a lot of pressure. Then what you need to do is have 10 feet of pipe between the regulator and the generator. That doesn't mean need to mean that the regulator is 10 feet away from the generator. The regulator could be right by the generator. You might just have to run some pipe down and back in order to get 10 feet of pipe before you actually go into the generator. And the purpose of that is just to provide an accumulator, provide some gas there, mostly for starting. Because if the regulator is right next to the generator, there's no gas in the pipe, and you can have a lot of instability of that gas regulator before you get the thing up and running. And some people have put expansion tanks like you see on your water heater in order to have a little bit of gas in there. But 10 feet of pipe does it and is just fine. Another thing is your shutoff valves. Now you need to have a shutoff valve, and one of the most common reasons for natural gas generator failure is somebody shuts off the valve. It could be somebody shutting off the valve that is a kid just playing out there, or it could be somebody shutting off the valve so they can work on the generator, and then they forget to turn it back on. So we recommend that you have a padlock on the valve. You want to padlock the valve in the open position. Now, of course, that valve will generally be able to be padlocked in the open position or the closed position. And if you want to make sure that nobody turns it on, you want to padlock it in the closed position. But my primary concern is padlocking it in the open position. We've had a number of service calls where we go out and find out that the reason the generator doesn't run is they turned the gas valve off, and they're not very happy at that point. Here's propane. Now, propane is considered reliable by authorities having jurisdiction. I've never seen an AHJ not consider it reliable, and it's often considered as dual fuel. In other words, a dual fuel generator runs on natural gas, but if the natural gas ever fails, there's a spring in the solenoid that switches it automatically to propane. Propane doesn't degrade, so you don't have the same problems as you do with diesel fuel. As long as it's sealed and you don't have leaks and so on, that's just going to be there forever. Then you have cold weather boil-off considerations. In other words, if you try to suck too much propane too fast, it may not be able to vaporize. And in that instance, you're going to have to add a vaporizer either to the generator or to the tank. Here's your exhaust. And you can see here that you need a flex connection. Anything that connects to the generator, whether it be the sheet metal that goes to the radiator, whether it be the electrical connections, whether it be the natural gas connection, everything must have a flex connection. And it amazes me, nobody puts in a hot water heater without a flex connection. And yet we see so many times people will just go ahead and pipe their natural gas right to the generator without a flex connection, and that's a bad one. You should have a condensate trap on your exhaust so that water doesn't flow back into the engine. You need to have a thimble, that's the part that goes through the ceiling or the wall, and it protects the wall from the heat, and so on. You can read these others. One of the problems that can happen is you exhaust under a building's air intake. That's so easy to do because you're just not thinking about it. The guy doing the generator is not the guy who did the HVAC system, and obviously you can't exhaust near a building's air intake or under a platform for reasons of carbon dioxide. Equipment location. If you have a legally required or an emergency generator, it must be permanently installed. In other words, if it's necessary for life safety, you cannot bring in a portable generator to do that. Now, you can bring in a portable generator while you repair or service the permanent generator, and in fact, you're required to do that if it's an emergency generator, but it needs to be permanently installed. You can see some of the other things: flooding, human threats, the generator or transfer switch, if it's a level 1, cannot be installed with the electrical service if it's a level 1, 480 volt and 1,000 amps or more. Generators should typically be 36 inches apart. You've got to have adequate ventilation and airflow, and outdoor units require 5-foot clearance from the building. What they actually say is 5-foot clearance from building openings, or what does it say? Combustible walls or building openings. So you need 5-foot clearance from combustible walls or building openings. There are times when you can locate it closer. And for instance, residential generators are very commonly located closer than that. And there are various rules. If you're interested in this clearance issue, I have a little write-up that I'd be happy to share with you. And in fact, maybe I'll just go ahead and send that to Tyler because it can be quite confusing. There are a number of factors that impact that clearance. Here's your fire considerations. You can just scan that. And obviously, you need to think about the fire ratings. Here's the failures. You want to minimize the effect of failure on one energy converter over the other. If you have 2 generators inside of a building, obviously a fire could affect the second generator and take out both of them. When you have a temporary, when you're whenever the generator is out of service, the code now requires you, if it's an emergency generator, to bring in a portable generator, and that's a real pain. And so if you have two generators paralleled, that's really nice because you don't need to do that. Vibration isolators don't require springs under generators. We go through rigorous testing to provide isolation within the generator. It's between the fuel tank and it's actually between the frame of the generator and the other components like the engine and the alternator. And that is a very sophisticated vibration isolation system. Don't mess with it. Closed loop cooling is generally required, so you need your radiator on the generator. And if you have a building that you want to keep that generator room warm, you're going to have motorized louvers, so they're going to open up if there's a power outage. They need to spring open and not spring closed. Here is the NFPA 110. Requires that you have a 21 light remote annunciator. One of those is shown here on the right. You need that for actually legally required or emergency systems. You do not need one for an optional standby generator. And you can't even get one of these things if you don't have an NFPA 110 generator that I usually call a heavy duty industrial generator. Here is NFPA 110. We talked about this last time, but it requires all of these alarms and shutoffs. So you've got level 1 and level 2, and then this is your control mounted visual or your control panel mounted visual. There's your shutoff and there's your remote annunciator. And you can go down there and you can see you need an overcrank, you need low water temperature, and so forth. Actually, this list determines what's on these lights here on the remote annunciator. And anytime you get an NFPA 110 control panel, it must contain all of these items, and all manufacturers will base their control panels on NFPA 110. Block and battery heaters. Block heaters are needed for diesel because you need to keep that engine warm. They're not necessarily needed for natural gas or propane, but they may be required by standards. The battery charger should have a charge time of 24 hours or less. Generally, we like that a lot less. Should be float equalized type. We typically use lead acid batteries. Then there are requirements in NFPA 110 for acceptance testing, and this is quite extensive and quite long. So we've showed you some of the requirements, like a building load test for 1.5 hours, and then a full load test, 30% for 30 minutes, 50% for 30 minutes, and 100% for 60 minutes. And all of this is makes your testing, your acceptance testing, more expensive, but it's required for emergency and legally required generators. And this all has to be documented in case the inspector wants to see it, which he generally doesn't. These are your weekly, monthly, and annual tests. You can just scan through there. It's important. The owner generally does the weekly and the monthly tests, and the annual tests may be done by a sophisticated owner, but more often is done by a generator service company. And all people who sell generators generally have a service arm. We certainly do. Here is a document in NFPA 110, because when you do your service, if it's an emergency generator, you must document that service. And somebody could come in and they want to see that you're documenting your weekly, your monthly, and your annual tests. If you don't have it documented, then you didn't do it. And so they actually have a maintenance schedule form in the standard if you would like to use that. Here's some more requirements. Emergency must start and run in 10 seconds. Batteries should be capable of 2 45-second cranking cycles. The voltage dip should be acceptable to the load. Emergency generators must have a permanent magnet generator on. That's an additional cost there over a brushless or a direct excitation. You need to have 2 sets of manuals. Again, emergency generators only. You have to have tools and testing devices for maintenance. Generally, there's nothing special there. You have to have spare parts. Generally, that's air filters, oil filters, fuel filters, and possibly belts. I worry about that because these, especially like belts, that may be there for 10 years. By the time you're done and you want to or by the time you have a belt break and you want to go out and find that belt that's been sitting in a hot warehouse, it may not be any good. So have concerns there. But in any case, that's part of the standard. You need to have training and you need to document your inspections. Finally, your fire pumps. Your fire pumps, we went over in NEC. They have to, even though they're not really an emergency generator, they may not be an officially designated life safety. They still have to meet all the life safety requirements. So you have to have a level 1 type 10 generator. They must run for at least 8 hours. Maximum voltage dip is 15% during a normal start. And they must support an across the line start as a backup in case the normal start method fails. Looking back, these are some of the things we've talked about, and we are now complete. So I'm going to turn the time back to Tyler.
Great. We've had a couple questions come in, but feel free to keep submitting. The first question is, how often are standards for NFPA 110 updated? What about UL?
So UL tends to be updated kind of on a regular basis, and I don't know that they have an official requirement to update them every so often. Generally, with the National Electrical Code and NFPA 110, they will update those every 3 years.
Great. As a follow-up question, is there typically any type of grandfathering on generators if standards or site conditions change?
Yeah, what a great question. The answer is yes, but the answer is a kind of a qualified yes. So you may find in places that have bureaucracies that get out of hand, they may actually go and try to make people with older generators upgrade, but that's very seldom. As a general rule, almost every place you go, even places like California or Washington, if the generator was legal when it was installed, it will be legal forever because of the grandfathering. And so if they change national electrical codes, if they change NFPA 110, you do not need to upgrade the generator. However, the testing is different. So even though you don't have to upgrade the generator itself, if the NFPA 110 standards change and maybe now they require a 4-hour load bank test, whereas 10 years ago they didn't require a load test at all, you are going to have to upgrade to the new testing standards because the testing standards are not grandfathered, but the actual equipment is, and you're not going to need to change the equipment.
Great. What are red flags that you may need to look into updating your generator system, even if it is grandfathered in?
Well, there's several ways of looking at this. For instance, if your tank has an incredible amount of rust on it, well, that might be a red flag. The biggest red flag is simply your reliability. If you find that that generator is having problems not starting, then that's a good red flag for wanting to update the generator. The reason why, frankly, I would say most people update their generators is simply time. They'll say, hey, this generator's 20 years old. I think it's time we replaced it. How long should a generator last? Well, generators should last probably about 25 years. And I would say if you have a generator that's more than 25 years old, it might be good to look at replacing it. But there is nothing in the standards that requires you to replace it.
How would specifications look different if you were writing one for life safety versus legally required versus optional generators? Also, what things should be written into all specifications regardless?
Yeah, so this could be a long answer, as you might guess, but I think it's a great question. The first thing I think is all generator specifications should say that the generator needs to be UL rated. A lot of times optional generators don't really have specifications. People will just look for a generator they like. and bring it in. If you have an optional generator, but it's really critical that you want to make sure that that stays reliable. Let's say that you're making drugs, and you've got drugs that if you have a power outage, you lose that whole batch of drugs and it costs you $100,000. Well, that's an optional generator, but it's a generator that's pretty critical that it be reliable. And so even though it's an optional generator, and we see this all the time, people will say, we want this generator to meet emergency system requirements. Now, what are emergency system requirements? Basically, you have to have coordination of the breaker. That may require an electronic breaker. You need to have a remote emergency stop. You need to have a 21 light remote annunciator that can be mounted in a convenient location where people are going to see that, generally inside of the building. You need to have a permanent magnet alternator. You need to have emergency vents on your fuel tank. And probably most important, the generator simply must meet NFPA 110 requirements. And that means it must have an NFPA 110 controller, and it must have all the proper sensors and so on to meet NFPA 110 requirements. If you require your generator to be UL, to meet all of the NEC emergency generator requirements, and to meet NFPA 110, you kind of covered your bases there, because they will fold into them a lot of these other things that I just have been mentioning. In terms of standards, or in terms of specifications, excuse me, we have a program that we've talked about earlier called Power Design Pro. It is the industrial sizing program. If you just go to www.generac.com, you can access that program, and it allows you to size a generator. And once you configure your generator, it will allow you to print out a specification. Now, that specification is still going to have a lot of options in it, and you're going to have to go through it by hand and decide, do I want this? Do I not want this? For instance, do I want an indoor generator? Do we want an outdoor weather protective generator? Or do I want a level 1 or level 2 or level 3 sound enclosure? Things like that you're still going to have to do by hand, but that will allow you to have a really nice spec to get started on. And again, specify UL, and if it's emergency generator, specify that it be fully rated for emergency service according to NEC and for NFPA 110. Now, if it's an optional generator, then you have a choice. You can buy an emergency generator that has all the bells and whistles for emergency, but not do all the acceptance testing. But I would say if you're going to buy a generator like that, I would want to spend the extra money on acceptance testing. It's really not that much. The installer or the startup person's going to have to bring out a load bank, and they're going to have to go through a complete battery of tests and run it for 4 hours, and you're going to have enough fuel to run for 4 hours. There's certainly a cost to that, but in my opinion, it's well worth that cost. So we do have, by the way, coming up, and it'll be probably another month or two, but we will have a webinar strictly on how to write generator specifications. And even with the hour that we're going to spend there, we'll still not be really able to get into detail on that. So we're also happy to help you with specifications. Call your EMC salesman. We'd be happy to provide you with specs or to review your specs and to talk about your application. And we very commonly will go out to your site and evaluate things and then make sure that the specification is correct. I think that's kind of a good thing to do anyway. It's nice to have somebody who does generators practically full-time just to check things over and to make sure that things are appropriate for what you really want to achieve with your generator installation.
We had someone bring up remote stops, wanting a little bit more information, specifically on when they're required, if they're required, and any other details about that.
Yeah, so a remote stop is a push button, And it generally is labeled generator or standby generator, remote stop. It's a big red mushroom head button. And there is already a mushroom head button on the generator controller that just comes standard. But in order to get to that, you generally have to have the keys, and you're going to open the door to get to the generator controller, and that mushroom head button will appear there. So you don't have to know anything special to shut down the generator. As soon as you open the door and see the controller, that big old red mushroom head is there, and pretty much everybody knows that's an emergency stop. If it is a legally required generator or an optional generator, that's all you need. But if it's an emergency generator, you need to have a remote emergency stop. Now, where does that need to go? They don't really tell you, but it could be in an electrical room. It could be in a let's say in a water treatment plant. Maybe you've got that thing where you have 24-hour a manned 24-hour station. Maybe they've got all of their controls for the water treatment plant in there, and maybe you put it there. Maybe it's in the hallway right when you go in the door to the facility. One thing I like to have, and it's not always done, but whenever you buy an emergency stop push button from us, I always do this, is I have a clear plastic cover that's hinged that goes over the emergency stop push button, because it's so easy for somebody to push that button. Maybe they're just playing with it. Maybe they push it in to do service, and then they forget to pull it back out, and now your generator won't run. And it could take a little bit of effort to determine that it won't run because of that emergency stop push button being pushed. And so that makes me a little bit hesitant to have emergency stop push buttons located in kind of places where the public can have access to them. Even in an electrical room, it's just so easy to do that and not realize that you've done it. One of the good things is when you do push that emergency stop push button, you will get a warning on the generator controller, so you are going to get an alarm. So it's not quite as bad as I'm making it out to be. But a lot of people who have emergency generators don't install that push button for that reason. And I'm not telling you to do that because the code requires you to do that. But it's only required on an emergency generator.
Great. It looks like that's all the questions we had. So we'd like to thank everyone for joining us, and we look forward to seeing you next time.